And welcome back, and it is the 12th of Feb, higher plus 5 a day, and let's go with the first question. Okay, so what do we have? So we have make A the subject, and we have an algebraic fraction. Good question. Right, I have to stop saying that every time, but I really do like these sheets. Now, the way I'm going to do this is you've got to remember that I want to end up with A equals. So there's a couple of ways to do it. I'm going to start actually by moving, so let's see what I'm doing. So I've got 1 over C plus 1 over B. And that just means I've got 1A and I don't have to worry about rearranging and doing things with A's. I'm also going to fix the right hand side now. So make the denominator B over C. So that's going to give me B plus C over BC. Now 1 over A equals that, which must mean in one go, this wasn't anywhere near as bad as it looks, was it? So A is going to be equal to BC over B plus C. Question done. Next question. Solve x squared minus 4x equals 11 using completing the square. Now I like it when it does this. Normally I don't, because I like it when you can do whatever math you want, but it just forces you to make sure you understand how to do different techniques. So let's complete the square. So halve the 4, which is 2. So it's x minus 2 squared minus the square of the 2, which is 4, and minus 11 is equal to 0, which means that x minus 2 squared, well, minus 4 minus 11 is minus 15. And if you add 15 to both sides, that gives you equals 15. So far, so good. Then I'm going to do the square root. Now, of course, this is the catch to the question, isn't it? So it's going to be x minus 2 is not equal to root 15. It's equal to plus minus root 15. And then when I add on the 2, that's going to tell me that x is equal to 2 plus minus the square root of 15. Now, it doesn't actually say here whether it wants decimals or real exact values, but this is fine. I think because it's a GCSE, not an A level, I would actually write both solutions out separately. So 2 minus root 15, 2 plus root 15. Excellent. Next question. Here are the first 5 terms of a quadratic sequence. Find an expression in terms of n for the nth term of this quadratic sequence. So what I need is the second difference. So 17 from 9 is 8. 17 from 29 is 12. 29 from 45 is going to be, well, 30, 15, 16, so it's going up by 4, isn't it? And 45 from 65 is going to give me 20, which means my second difference, so 12 minus 8 is 4, 16 minus 12 is 4, and that difference is 4, which means my A term is going to be equal to half of 4, which is 2. Now let's use my technique again. So write out the sequence. So 9, 17, 29, 45, 65. Then I know that A is 2, which means my nth term is 2n squared plus something. So if I write the 2n squared underneath, so 1 squared is 1 times 2 is 2. 2 squared is 4 times 2 is 8. 3 squared is 9 times 2 is 18. 4 squared is 16 times 2 is 32. And 5 squared is 25 times 2 is 50. So it's slightly more complicated, this one. Then take the numbers away. So 2 from 9 is 7. 18 from 17 is going to give me 9. 18 from 29 is going to give me 11. It's going up by 2s, isn't it? 32 from 45 is 13. And 50 from 65 is 15. So this sequence goes up by 2s. And I need to add 5 to get the first term. So therefore my nth term, let's write it in a different colour so you know what I'm doing, is going to be un is equal to 2n squared, where I got the 2 from the second difference, plus 2n plus 5. Next question. Right, it's a proof question. So if you've heard me do these before, I won't write all the words out precisely, but I'll make sure I say the words out loud or write some of the words you definitely need to write. Let's see what I've got. So DE equals DF. So DE is equal to DF, which is equal to FG. Right, so I have two isosceles triangles. And then I need to prove that EDF is equal to 180. So I want EDF is this angle here. Okay. Now, as I have probably also said before, if you've seen me do some of these videos, I like to give it a quick run through first so I know where I'm going. So I'm going to say that this angle here is theta because of isosceles triangles. This angle here is 180 minus 2 theta because angles in a triangle total 180. This angle is 180 minus 180 minus 2 theta, which is 2 theta, which means this angle here is 2 theta, and therefore this angle is 180 minus 2 theta minus 2 theta, which is 180 minus 4 theta. That's what we're going to do. Let's now do that a bit slower, so I'm writing it down. And now I'm doing this, I'm thinking we've seen this question before, haven't we? Anyway, doesn't matter. So I'm going to say that this angle is theta and write down the angle DGF. So DGF equals theta. And then you don't just write the word isosceles, you need to write isosceles base angles are equal. Okay, that's absolute minimum you want to write. Then I'm going to say this angle here, so this angle is DFG. So DFG is equal to 180 minus 2 theta. I'm going to write it here, so 180 minus 2 theta. And you want to write, because angles in a triangle total, do not write the symbol triangle in your exam, total 180. Then I want to say that this angle here is going to be 2 theta, so EFD. It's a very tedious question, isn't it? EFD is equal to 2 theta, because angles on a straight line, let's write slightly neater, straight line total, and there's a total we need, 180. God, it's still going. Angle DEF, so angle DEF is equal to 2 theta. So angle DEF equals 2 theta. And then again, you want to say isosceles and base angles. Base angles. And then finally, and it's the same rule, just use, I'm going to draw a little line here. Hopefully I've got some space below. So then finally, the thing that I need to prove is EDF is equal to 180 minus 2 theta minus 2 theta, which is equal to 180 minus 4 theta, because angles in a triangle total 180 degrees. Again, do not do what I've just done where I'll just write this. You need to write total 180, base angles are equal, etc., etc. Either way, question done, sort of. Next question and final question today. The minimum point of a quadratic graph in the form this is this. Find A and B. Okay, there's two ways of doing this. So way one is to expand two linear brackets, then compare. Way two is slightly clever. It's remembering that if I know what the minimum point is, I can use my knowledge of completing the square to say I can write that as x minus 6 all squared plus 3, because that's what gives me the minimum point, 6, 3. And if I expand this, that gives me x squared minus 12x plus 36 plus 3, which is x squared minus 12x plus 39, which in other words means that by comparing, a is minus 12 and b is equal to 39. And that is the final questions today done. Usual mix of great different questions, really testing you understand those different skills. Usual thing, do like and subscribe. Any questions, please leave in the comments down below, and I will talk to you for the next one. Thanks all.